In this video, I'll show you how to solve the ALEKS problem called using reactant reaction order to predict changes in reactant rate. So for this problem, it's going to give us some information about the rate law for the reaction. It's telling us that this reaction is second order in N2 and second order in H2. From that information, we can write a rate law. Rate equals K N2 squared H2 squared. Again, I'm getting this information because it's telling me that it is second order with respect to N2 and second order with respect to H2. Then it's going to give us a whole bunch of data for one particular trial for this reaction. It's giving us the rate, the concentration of N2, and the concentration of H2, which means we have enough information to calculate the rate constant K. And that's what we should do with all of the data in row number 1. The rate of the reaction is 66.0. I'm going to leave the units off of everything to save space. The concentration of N2 is 2.11, and that needs to be squared, and the concentration of H2 is 1.14, and that also needs to be squared. And like I said, we're going to use this to calculate the value of K, the rate constant, which I get 11.41. I'm going to leave an extra sig fig. It's asking us to round these to 3 sig figs. Once we know the value of K, we can work on the rest of this problem. So for the rest of this problem, it's giving me some data about N2 and H2 and asking me to calculate the rate. The rate constant K is literally a constant, so it doesn't matter what the concentrations are. I'm going to use this rate law again, but this time I know the value of K, 1.41. I'm going to plug in the data that I'm being given in row number 2, 4.83. Don't forget that that needs to be squared. 1.14, that also needs to be squared. It's not always going to be squared. You've got to pay attention to what the problem is telling you in terms of the reaction order, and we'll use this to solve for the rate. For part number 2, I'm getting, for this one, I'm getting 346. And then for row number 3, we're going to do the same thing. Use that same rate constant, 11.41. The concentration of N2 is still 4.83. That still needs to be squared. The concentration of H2 is 0.498, also squared. And this is 66. To 3 sig figs, we need to say 66.0.